So today we're going over the June 2022 Edexcel Higher Maths paper. We'll go over question 21, which is the last question in the paper. Probably one of the hardest questions in the paper, just testing a bunch of different topics. So yeah, let's dive straight in. So question says, diagram shows 3 circles, each a radius 4 centimeters. The centers of the circles are A, B, and C, such that ABC is a straight line. AB equals BC, which is equal to 4. So immediately this tells us, they all have the same radius. So they must all be the same circle, same size. Work out the total area of the 2 shaded regions. Right, give your answer in terms of pi. Okay, so initially when you might look at this question, it might be a bit daunting, sort of like where do you start? So it's sort of all about logically working through it. So we see here we want to find out these 2 areas. And it's apparent that to get that, we focus on the area of this circle here, take away sort of these 2 oval shapes. So really, if we find out the area of this oval shape and that oval shape, we can find out the answer to the question. So just make that clear. So we find out the area of the circle, which is pi r squared. Put it up here. Minus, let's just call it oval 1 here, and oval 2. Oval 1 minus area oval 2. That gives us our answer. So this is our blueprint to how to answer the question. Okay, so the next question is, how do we find the area of oval 1 and 2? Well, the good thing is that because all of these circles are the same, the area of oval 1 equals the area of oval 2. So we only need to focus on one oval. So I'm just going to ignore this whole circle for the time being. Just focus on this one. You could choose either one, but I'll just focus on this one. Now I'm just going to add some points here to help us with the question. I'm just going to label this point D. Label this point E. All right. So initially, when you see a question like this, there is no formula to work out that area. But you can just deconstruct the diagram, and that's what you basically have to do to try and answer this question. So if we split it up into these 2 bits, we can see that we have one segment here and one segment there. This segment is a segment of this whole circle, and obviously this one is for that whole circle. Right. So if we find out the area of each of these segments, which by the way they're equal, we can find out the area of the oval. So again, let's just call it segment 1, segment 2. So segment 1 plus segment 2 equals oval area. All right. Okay. Right. Again, just to add in some construction lines to help us out. We'll just focus on the left circle for now. We can use the area of a segment to find out the answer to 1/2 of the oval or the segment. So our sort of new challenge is to find out this area. Now I'm going to call that segment ADBE. Now, if you recall, to find out the area of the segment ADBE, you'll need this angle here, this one here. So I'm going to call this angle X. Different color. Let's call it angle A. It's already there. Put the little angle sign there. Okay. So to find the area, it's the angle A over 360 degrees. That's the angle of the full circle. So that's the fraction of the circle that represents the segment times by the whole area of the circle by r squared. Now we know r is 4, so we can just put that in immediately. Pi 4 squared. Alright, okay. Now, the question is, what we don't know is this, angle A. How do we find this out? Now, it does take a bit of just looking at the diagram and finding out some construction lines. There are different ways to do this, but the easiest way is to use the question. The centers of the circles are ABC such that ABC is a straight line. So we can draw that in. Now we know, for example, BC is the radius of both, the right circle and the middle circle. We also know that, that it is this radius here as well. And it's also that radius. All of which are lengths 4. As told in the question. So if everything has a length 4, then this DAB is an equilateral triangle. And as you know, angles in an equilateral triangle is all 60. So it's using a bit of knowledge here that, hopefully we would know from revision. But we can go ahead and write that out. So triangle DAB equilateral. So this angle here, which is again we have to notice this is exactly half the angle. Why is it half of angle A? Well, because of the geometry of how the circles are laid out. Angle ABC bisects angle DAE. So triangle DAB is equilateral. So I'll call it angle, therefore angle DAB. Just to be clear, let me call this angle DAE. So to be clear, angle DAE is this angle DAB is that angle. So therefore angle DAB is equal to 60 degrees. Okay. Now, if angle DAB is 60, then angle DAE is equal to 2 times DAB as line ABC bisects, which means cuts in half, angle DAE due to symmetry. Okay. Now, so we know angle DAE. We can plug that into the area of the segment. Angle DAE is 120, 2 times 60. Pi 4 squared, 16 pi. Those two cancel, that's 1, 3. 16 pi over 3 equal to area ADB, which is the segment. Okay, sorry, that's the sector. Okay, so we have found the angle, we have found the area of this whole thing. Now we just want that. So we need to take away that triangle DAE. So let's calculate that. Okay, so if we just zoom in a bit, it might not be apparent straight away, but the area of a triangle is half base times height. Base here is that line here. We can calculate the length of that. Height is that one there. We know that height is 2 because this whole thing is 4. And again, because of symmetry, this exactly cuts it in half. And if you're unsure about the symmetry bit, you can just see from your drawing, everything looks symmetrical. And if it looks like it, most likely it would be it in the exam. I know that's not the correct way to do it in the maths exam, but basically just when in doubt, sketch it out. So that here has a length 2. Right, so just make it clear, that's 2. Alright, I know the drawing's getting a bit convoluted, but just bear with me. Okay, so I'll just draw out the triangle just to make it a bit clearer for us. That's A, that's B, that's E. That here is 2. We want to find out what the length of DE is. DE. Alright. An easy way to do this is to use Pythagoras. So we know that that's 2. This is 4, this is 4, there's a radius. Let's just split it up into 2 triangles. Triangle there. I'm just looking at this triangle here. So okay, let's call that point F in the diagram. So point F. Okay. So we're looking at triangle DAF, which is now this smaller bit here that we're looking at. 4, 2, right angle. What's the area of this? Again, Pythagoras. 2 squared plus x squared equals 4 squared. X squared 16 minus 4. X is equal to square root 12. X is equal to, again using surds, 4 times 3, 2 root 3. Okay, this implies that the line DE is equal to 2 times 2 root 3 equal to 4 root 3. So we know the length of DE. Now we can find out area of triangle DAE is equal to half base times height. So that's equal to 1/2 times by base, which is DE, which we calculate to be 4 root 3 times by height which is 2. Those two cancel out. implies the area is equal to 4, 3, DA. Now let's go back to our plan. We wanted to find out the area of the segment DBE. We want to find out this area. So we have found out this area, DBE, which is ADBE, which is this. We have found out the area of this, which is this. So if we take the 2 away, we should get the area of this. All right. So, okay. I'm looking at the area of the segment now, not the sector. Segment DBE is equal to ADBE minus DAE, which is 16 pi over 3 minus 4 root 3. All right. Now, that's the area of the segment. Now remember our plan again. We want to find the area of the oval, and the area of the oval is the area of the segment 1 plus segment 2. So oval area 2 times by 3 minus 4 root 3. Okay, to 32 pi over 3 minus 8 root 3. Now there's two ovals, remember, so let's call it total oval area to 2 times by that. Okay, so the area of the circle is pi r squared. Take that away from all of this. This shaded area is the area of the circle. That's the total oval area. That's equal to 16 pi minus 64 pi over 3 minus 16 plus 16 root 3. So that is equal to 48 pi over 3 minus 64 pi 3 plus 16 root 3. Right. Now this would be equal to 16 root 3 minus 16 pi over 3. Okay, so that should be the answer for this question. So that would be the area of the shaded bits. Again, just to go through what we've done, we have first calculate the area of the sector. Okay, well, first thing we did, we identified we need to find out the area of these ovals, and we use the factor of symmetry that you could just add together, both of them. To find the area of this oval, we're trying to find the area of this segment. To find the area of that segment, of that segment, you find the area of the sector, right? And the area of that sector, we found it to be this. How did we find that? We used the area of the sector equation. We identified that this angle is 120 degrees, using the fact that this angle is 60 from the fact that this is an equilateral triangle. All right, so we got the area of the sector. Now, to find the area of the segment, you take away the triangle. Now, the triangle area is equal to half base times height. We found out this height using Pythagoras. Okay, now that height was this. Sorry, that height was this. And the area is actually this as well. So we took away this area from that triangle, this from this, to get the area of this oval, of this segment, sorry. That's the area of the segment. Now the oval was just 2 times that, because it's that plus that, and they're both the same thing. Same size, same shape. So it's 2 times that is the area of the oval. Now there's 2 ovals, so we multiplied our answer for that. Now that's the area of all the ovals. And to find the area of the shaded, which is what the question asked, area of the 2 shaded regions is the area of the circle minus the area of the ovals. Alright, so if this is the area of the 2 ovals, this is the area of the circle, you just take away this from this, and once you simplify further, you simplify down, you get to the final answer of this. Yep, so this is the structure of the question. You could see that basically to answer this question, you just got to be really methodical. And yeah, I hope this helps. Let me know if you have any questions. Thank you.